welcome everybody. My name is Jonathan Ogg. I work for Sofco at the bottom left there, and today's presentation is a case study in terms of one of our deployments that we did with Saft batteries. And it was a deployment of a supply planning and production planning system in France. So in terms of what we're going to talk about, I'm going to be very quick on who Sofco are, just so you know who we are. I'll give you some more detail on Saft batteries, because that's quite important in terms of the context of this particular project. As well, we'll talk about the objectives that they had within the project, what we actually delivered. We'll take you through that in some detail, and results and key learnings from the project. So first off, a little bit about Sofco. We are a software vendor and we specialise in end-to-end planning systems. We don't do anything transactional at all, so we're always linking up with major ERP systems and other systems. See here the main products going along the top: demand planning, supply planning and production scheduling, some additional add-on modules. We are the authors of the software, we sell the software, we implement the software, and we support the software based in the UK. We do different levels of planning, so from the longer term S&OP, integrated business planning, down through the operational horizons, for instance 13 to 26 weeks, and then when we get into the world of production scheduling, we're working down in the minute. We'll plan in volume, we can plan in value, multiple units of measure, multiple levels of hierarchies. We also have a product that's out of the box. Those are our Sofco Enterprise Suite products, and they come with a project to deploy them, whereas this is a cloud-based product out of the box for people who are interested in forecasting. From on the left-hand side, a company with their first steps, maybe a startup type business, to the professional on the right-hand side. And this is all of the functionality that we tend to build into our enterprise models, but this is out of the box and it's deployed in days rather than the project. Customers, three main sectors: food and beverage, specialty retail, manufacturing. Hopefully you'll recognize some of the logos that are on there, and different sizes of customer. One of these well-known food companies, there's one person on a laptop doing the forecasting for them, whereas Hempel in manufacturing, they've got hundreds of people globally planning, and with Saft, lots of complexity, which we'll talk a little bit more about. All of the specialty retail solutions, they are supply chain solutions. So things like forecasting, store replenishment, DC replenishment. Okay, that's Sofco. Saft. So, number of key things about Saft. They're a big global organisation. So you can see some of the markets they're in down at the bottom here, from aerospace, going to the right through medical telecoms to utilities on the far right-hand side. Some big numbers here as well in terms of the number of countries they operate in, manufacturing sites, turnover, employees. And we first came across Saft in 2019. So they were looking for a new planning system for a reason, which I'll go into shortly. So we were invited to participate in a competitive process. They took us through a classical process: initial presentations, requests for more detailed information on functionality. We did some custom presentations where they gave us data and specific scenarios that we had to prove to them before a final proposal with detailed project plans, costings and everything. And happily we were successful. So Saft the business, initially to kick it off, they decided to do 2 sites in France. First one being Poitiers, and the second one being Bordeaux. Now, as well, the type of batteries they make as well, they're not the sort of things that you go to Tesco to buy, your AAAs and that type of thing. A lot of these are complex assemblies. So for context, this is the Poitiers site. You can see the picture at the bottom right-hand corner, with the large building being the plant, offices in front, along to the side, some R&D office areas and some further offices. two main divisions, civil engineering, defence and space. You can see the scale of the site in terms of hectares or metres, number of employees. And if we go to the Bordeaux site, you can see, two different production units, the elements and the batteries. See some images there. And the Bordeaux, much of the same again, round about the slightly bigger, I think, in terms of the number of employees, slightly different metrics. But you can see there's a lot of different products and a lot of batteries produced in these sites. Some of the Bordeaux products, I think that one on the bottom right is, I've never seen a battery like that before, but that's quite an assembly. Right, where did this start? What actually drove this? And this started from really a classical position. I mean, over the last, however many years, a lot of years I've been doing this, I've come across a lot of businesses, and the start point is very similar to the position that Sofco were in. I believe there's still a lot of businesses out there. And the first thing you see at the top highlighted in red, manual planning using Excel. And Excel definitely has its place. We know it's a flexible tool that can use, but it can have limitations as well in planning. I'm not going to go into those. I think those have been discussed and documented elsewhere in plenty of detail. But equally, problems with constraints. They had a lot of constraints in these particular factories, and they needed to take them into account when planning. There was a lot of manual activity, all of the works orders. They were having to key manually into QAD, which is the ERP system. So a lot of downtime with administration rather than planning, and difficulty synchronizing and desynchronizing all of the different production operations, and particularly over the different time horizons, because they're wanting to look up to 3 years into the future. So objective for Poitiers, they want to do what they call a massive and easy replenishment. These are Saf's words and slides, by the way, not mine, but I like the word massive. And improve their acknowledgement time. So by acknowledgement, when they get a new inquiry from a customer, it was A, taking them a long time to come up with the date for delivery to give that customer, and B, an even bigger problem, giving them an accurate date. You'll see this theme recurring. Bordeaux, different words, written by different people, but you can see similar sorts of problems. Manual planning, complexity of planning. Down here, difficulties. Down here, no way to manage unplanned customer orders and a lot of unplanned events that you get going on in a significant manufacturing operation. So why did this start the issue? What were the things they wanted to fix? Number one, right at the top, commit an accurate date to the customer. They had long lead times, they had a lot of late deliveries, and as well, I think customers can kind of forgive a long lead time if you deliver when you're precisely when you say you're going to deliver. They were giving dates and not delivering against those dates, and that's a real problem from a customer service point of view. They wanted to improve the OTD performances, on-time delivery performance. They wanted to sort out the planning processes because they weren't robust. I think you probably know with Excel, you can often have these incredible Excel sheets for planning, but only the person that wrote it knows really how it actually works. And the IT just look at it and wash their hands of it because they don't know how they're going to support it. And they needed something robust. They needed it linked in with the S&OP, and as well, multi-sites needed to do that, link those in properly, and as well, they wanted simulations as well. So what if, the classic question in planning. So objectives. They had 3 simple objectives. Now, to me, when in a project like this, objectives are really important, because this was a significant project. It involved a lot of people and a lot of time. And one of the things, when you get into the detail of projects like this, you can kind of go off in tangents and down rabbit holes in a corner and in a direction that's actually away from the objective. So we started out with very simply having 3 key objectives: on-time delivery, planners and product productivity, but finite capacity planning. So considering all of the constraints in the business. So this isn't just production lines, it's tooling, it's availability, it's technical rest times, it's labour in certain instances, and as well sort out service level agreements with customers and internally. So with the relationship with the customer services, with the planning and with the factory as well. So those objectives are important as well. As you go on, after we'd gone live as well, they'd be asking for change requests, and always point of reference, does what you are asking for contribute to the objectives of this project? It's key as well, keeping it on budget and in scope. So some objectives in more detail. So top of the list, client benefits at the top, gain our clients' trust. System deliverables, so what do we need out of the system in order to meet that ultimate objective of the client's trust? You can see I've highlighted a few in red. Resources again, anticipating shortages. So I'm sure we've all seen sort of firefighting situations in manufacturing. I spent 17 years in manufacturing before I moved to work for a software vendor, and I've seen some firefighting go on, and we know it still goes on in a lot of businesses. So anticipating things and acting ahead. And as well, a framework as well. So this was an important one, in fact, two very important ones. Help the internal players spell out the rules of the game. So this is again back to that relationship of customer service, planning and production and materials and everything else that goes with it, and sorting out data as well. And I'll show you shortly why the data was important. So when we started the project, we decided the best approach was to take a template approach. We were doing two sites, starting together, and these two sites were kind of, the reason we did that, one, they had the people who were really willing to buy into the project, but as well they were considered good examples of what a generic SAFT would look like. So we started off with the startup phase and did a more detailed scoping exercise, and then began with the Poitiers project. So here you can see at the top, ran some really detailed design workshops, and these design workshops would determine what that template looked like for SAFT going forward. We got some people from Bordeaux involved in this as well, just to check that it was actually going to be a good fit straight across, and then from there we moved into the build phases, the testing phases of the project, and the go live. But we actually ran the two projects in offset parallel. So we started Bordeaux about a month to 2 months after Poitiers, and we just took the Poitiers design and did a gap analysis to make the changes, and then applied those changes to the build that we'd already done for Poitiers to really reduce the deployment time for future sites. Okay, they had to have a new process as well. They were used to working with Excel and manipulating data and pulling it from files from here, there and everywhere. And it was a very slow process as well. Nothing happened dynamically. So what we wanted was where we could, we wanted to automate things. And equally, but it still very much needs manual input. I think planning is not one of these things where you're suddenly going to have this magic button and push it and that's all you do all day. I don't think that's the reality of manufacturing, at least not for me. So you see the key processes starting on the left-hand side. We need to bring the data in through constraints, demand, plan, analysis to getting a feasible plan. On the far right-hand side, you can see either three little cogs, which means the system is doing the work for you, or where there's a person, there's some user intervention or possibly review and some actions. So we started off with the data. So this happens at SAFT overnight, every night, automatically. Nobody does anything, and if something goes wrong, they get a report, they tell them what's wrong, and they fix it. Because I'm sure, has anybody got perfect data out there? So there are still some issues from time to time with data. So look at the data in a little bit more detail. So there's quite a bit of complexity here. So at the point of the data as well, there were a couple of principles. One, we wanted to join up all of the systems because the data was quite disparate. And secondly, we wanted the rule of there is only one place to enter and maintain master or transactional data, and therefore that must flow towards the other system. So at the top you can see they had QAD and other systems. So if you created a new part, for instance, or a new product in QAD, that would automatically flow through to the Sofco planning system. Same with the outputs and the works orders. The other thing they wanted as well was they wanted some real specifics in terms of works order numbering, because it had to match the numbering with QAD, and also they had quite a bit of standing text which they issued to the shop floor depending on products. But you can see the flow of the data, and the loop closed at the other end with the update of works orders. Now, in terms of putting this together as well, they were really short of IT resource to gather this data together. So you can see on the left-hand side they had data in the MDM system, Master Data Management, they had data in QAD, and the forecast was in Excel. And their IT did not have the time to transform all of this data and get it into the right state to go through the planning system. So what they did was they created a data warehouse and they just effectively dumped all of their data in there. And then the Sofco technical team did all of the IT work for them. So we went in to set up the ETLs, so we did our extract, transform and load, moving into the staging area, which then we'd validate their data before putting it into Sofco, and this happens daily, do the planning and send it out again via the same route. So all joined up, and without us doing that, that could have stopped the project because the IT just had no resource. Had to model the constraints of the business in the system. So this is a typical bill of materials and routing example that they gave us, and this is a simplified version of some of the ones we actually came across. So on the left-hand side, all of the different components that go into a battery through component preparation, cell assembly, finishing, all the way down to consignment. But you can see the extra complications. You have individual components feeding in at different levels of the bills of materials. You had independent demands, so sales orders, as well as for finished products. You'd have for spare parts, sub-assembly replacements, potentially any component within there. And the routings were complicated further by the fact that alternate resources, so for instance cell assembly, a particular cell could be assembled on potentially 1, 2 or 3 different production lines, and each of those lines possibly had a different throughput rate, possibly a different labour requirement. So all of this had to be modelled in, and they keep changing components, so the routings had to be time effective so that when components were going to be replaced in the future, we could run out the stock of the old components and bring in the new. And the size of the model as well, if you look at the numbers on the top right hand side, it's a lot of data, so it's this times an awful lot of times. But this is important to the system. In fact, I think the data as a whole, I was thinking if without the right data in there, it's a bit like having a satellite navigation, expecting it to take you to where you want to go, but if you put the wrong address in, where do you end up? And I think the data is really important. That was part of the shift here. I realise you can't see this, and it's minute detail. If I just point out a little bit, this is the rechargeable cell area at Poitiers, primary components, cell production, battery assembly at the end. As you can see, the battery assembly is fed by cell production and rechargeable. You've got all of the tooling in there. But can you see the red dots? I'm sorry if anyone struggles seeing colours, but all the red dots, those are the finite constraints or the bottlenecks in the factory. So they had to work within those bottlenecks, and that includes all of the tooling as well. And there are other constraints. Occasionally certain key types of labour were also constraints in the planning process. So I think what I'm trying to get across is the complexity of the problem that we're having to deal with. Bordeaux, even more of the same. I'll move straight through that one. So that was the data. The other thing was demand. So often when you think of demand, you think, yep, we've got a forecast, we've got some customer orders, we might need to do some forecast netting or some consumption. But SAFT, again, it was slightly more complex than that. So these are all at Poitiers, all of the different types of demand, particularly in terms of sales orders. And when they're doing the planning and given the finite constraints, what they want to do is they prioritize. So basically, first off, we satisfy past due orders. After that, we satisfy confirmed orders, and so on all the way through down to the forecast, MTS, make to stock, and make to order. So that demand has to be reflected all the way into the production and down through the routing and the different stages of the manufacturing to support that. Bordeaux, slightly simpler. Right, so that all involves people's input or the movement of data. How do we actually then get the system to calculate that plan for them? So this runs automatically, and they get a brand new plan every morning, and they can run subsets of the plan, rerun it through the day should they wish. So on this, we've already talked about the demand and the resources and the routes. They also, of course, have to consider all of the inventory and work in progress. So they have inventory, for instance, that may be tied up in quarantine but could be released at a particular time. They have some rest times as well that before they can release product into manufacture. And at one level, they're a bit like a food company. They have expiry dates on batteries. So you can't just go around piling up stock everywhere, because if you can't sell it before it runs out of date, it was pointless making it. So multi-level bills of materials at the right-hand side there as well also need to consider reject percentages, dwell times, and a lot of your standard parameters as well that you get. And of course, these were all in the different systems as we saw earlier. These are then processed through the Sofco FPA algorithm, so finite planning algorithm, quite simple name. Output being at the middle bottom there, planned orders, and inventory projection, and workload and capacity. How is it actually doing that? So pretty straightforward, really. Calculating all the net requirements through the bill of material levels, calculating pegging. So by pegging, I mean the relationship between from the customer order or the forecast at the top level through each individual works order or piece of inventory that's connected to that. And that's really important if you want to respect the priorities in terms of the customer demand. Respect all of the constraints, and here key restraints are capacity, material availability, lot sizing, lead times. And if there is a shortage of material, the system is set to, right, do not plan the finished product. If you have no material, you can't make it, therefore use the capacity on something you can, sort out your material when it's available, then, or get the new date, we can put it into the plan and the system will recalculate. And as well, the way they approach the different orders as well. So in the short term, they want to get customer orders through, and there's a planning rule there that says make them as soon as possible, grab whatever materials and capacity you have and get those customer orders satisfied. This is in the first 20 weeks. And then after that, make the forecast, but make it as late as possible, so make it JIT. And then repeat the process through the longer term horizon up to 154 weeks. So they've now got that shorter term operational plan, but they've also got that longer visibility going out 3 years. And given the amount of capacity that they don't have, because this factory is seriously loaded and seriously full, they need that visibility for resource planning in the longer term and linking in with the S&OP process. So every day the planners do daily analysis on the plan. So they look by exception. You've seen the scale of the number of products that they have to deal with. They don't have an army of planners. You know, you can count the number of planners on your fingers without needing your toes. In fact, probably just on one of your hands. So they work very much by exceptions. So key exceptions, they get a summary on screen. It tells them how many, what type of exception, how many there are, and then they can navigate to the detail. And key things they're looking for in products, things like stock out. So if I'm stocking out, what it means is I'm going to let a customer down. Okay, I should always be at least in zero or positive stock. Under safety stock, some products that do carry stock, particularly make to forecast items. Unconfirmed orders. If an order is taking too long to be confirmed, we want to know about it because there's a customer waiting. Blocked orders, and with capacity as well, anything that's a bottleneck, the system is set that they cannot exceed 100% of the capacity. And if they can't, and if there's more demand than capacity, that's what generates the set exceptions in terms of stock out, etc. But some resources, particularly labour, are unconstrained, so they can look at the utilisation, and if they're overloaded, they can change shift patterns and things like that, and bring in additional labour work overtime. So those are the exceptions. How are we doing for time? Okay. At the end of it, they publish a feasible plan. So one part of the plan and report goes into the S&OP process, and as well they output the orders to QAD. They're outputted automatically. There is effectively, they've got a release process and they're released en masse, so there is no rekeying of works orders into between the planning system and QAD, which is the ERP, and where they process those works orders. But a really important thing for them is the available to promise report, and we actually had to do a whole presentation and proof of concept on this for them, that they could give us, we could have a plan, and that plan would remain untouched. We'd then import the confirmed orders, and in a parallel scenario we'd execute the planning algorithm with the rule is can't touch any existing orders or demand, so new unconfirmed orders, if required, either use available stock, or we have new production orders, or we need to order new materials. How long is that going to take? System does that, spits out the dates in a report, or they can look at it online. That report goes off to the customer services. The customer services then either agree, disagree, negotiate on the dates, and when they confirm them, they come back into the system as now confirmed orders and get built into the plan with those dates against them, knowing that at the time that they promise those dates, that is a feasible and achievable date that they're offering. So key part of the system for SAFT, really important. S&OP, so they're joined up to the S&OP system. So they get a lot of outputs that come from Sofco that are fed into this meeting, and this is where they're really resolving the conflicts in the plan, because it's a full factory. There are always going to be conflicts. And often when, particularly if you're looking at a particular product type, or you've got particular customers where, and the question is, who is it do we satisfy work and with first, because all things are equal in terms of priorities and other commercial circumstances. How do we decide? What they typically go to is some of the financial measures at the end. So in here we've got revenue, cost of goods sold, and margin, and they'll make the decision on the margin when all else is equal, in terms of who gets on time and who doesn't. Okay, go live. So that's the kind of the scale of the problem. That's the solution that was put in place to actually solve it. How do you then move across from your existing planning systems to an automated system with user intervention? So basically they went parallel running. Okay, for obvious reasons, to mitigate risk. Now, we have done a big bang before. We did a project in the Netherlands quite a few years ago, and there were 4 factories, and they were so interdependent you couldn't break it up into little subsections. And a big bang is you have to be sure before you hit the button and go. You have to be really sure. So they did parallel running. They used their Excel systems. They kept keying the works orders manually into QAD. And then from there, they ran Sofco in parallel, and they were checking and comparing the plans. And when they were really comfortable with the Sofco plan, only then did they say, right, we're going to turn on the automation for the works orders and to take out all of the keying process. and they turned them on, and you can see the Poitiers go live. They did it section by section, so you can see rechargeable batteries, primary, and you can see the times and the dates when they've done these things, and they did the same process, again slightly off parallel in Bordeaux, to get the system up and running and properly bedded in as well. They wanted it bedded in before they turned off and stopped using the old Excel systems, which I think was a good approach for them. You know, you've got to reduce risk in things like this. So where are they now? Where have they got to? Well, think of the objectives which we started with. I mean, so on the left-hand side here, these are some of the things that are contributing to the business benefits. So more accuracy, planning simulations, all the planning data up to date every morning, constraints are modelled, the plan is feasible and automatic, the whole factory is considered and planned as well. And then the big thing at the bottom, business benefit, they got the OTD, or the on-time delivery performance they were looking for. As a result of that, better usage of capacity. They're not constantly chopping and changing and setting up machines, and they've got the right resources lined up at the right time, and the different stages of the production synchronized accordingly. So with that as well, improvements in inventory control, production efficiency. I'm sorry they don't publish the real numbers publicly. I'm sure you understand some of the reasons why. Not even to us, actually. In fact, especially not to us. So what were some of the things that they actually learned here? So starting at the top, resources. One of the things with planners, I don't know what your experience is with planners, or if any of you are planners, I very rarely find a planner that is not extremely busy and in demand and quite pivotal in terms of what goes on within a business. So how were they going to do this? Because we needed the planners in the project, because all of the expertise, they knew the systems, they knew the products, they knew the environment, they knew the problems that they had and wanted to solve. So the approach that SAF took was that they decided, right, we're going to give the planners 2 days a week, only during the design phases and the UAT phases, so the user acceptance testing, because they have to do that. These are the people that know it. I mean, I've seen companies bring other people in to do this and use outside consultancies or use IT people, and my experience of it is it doesn't work, because all of a sudden you then give it to the planners and they say, yeah, you know, that doesn't quite work like that, sorry. So this was really critical. And what they did was, yes, they had to backfill some of that time. You can't suddenly ask people to work 7 days a week. But they gave them the resources to be able to do that. The other thing was they added a new full-time role, both to the project and to the business, and this was about managing the data. You've seen the data, the amount of data and the complexity that they had to deal with. So they brought this lady into the project, a lady called Oksana, and she was a real detailed person, and it had to be right. And as well, she really understood the manufacturing process. She'd worked in planning, and she knew the implications of inaccurate data or data that was missing or in the wrong places. So that made a big difference for them. And as well, it contributed particularly to the next bit, which was the business process and data management. So you see in the red there, change the paradigm. By changing the paradigm, what they wanted to do was they wanted to make sure that they focused on the inputs, that they gave the system all of the correct inputs so that it could do its work in terms of the automation, and they would deal with the exceptions. So in changing that paradigm, it's a different attitude towards data, and as well, it's a different attitude to process as well. So that was really important. And as well, but APS and planning knowledge. SAF had never actually done this before, and they had experienced planners, but a lot of them had worked for a long time at SAF, so they didn't have detailed knowledge of what they called APS, Advanced Planning Systems. So they decided to engage an external consultant. So he was on SAF's payroll, but they also selected someone that knew about Sofco, and it was really helpful because he understood our applications, and he acted as a kind of bridge at times between us and the SAFT people, and he was really good at spending time with them, particularly when we were off-site during the build phase, explaining processes and the implications of decisions that they'd made, and really just to help with drive that paradigm shift across. And he also did the project management, and that for SAFT, that worked really well. Right, so how did all of this work out? So this, if you look at the bottom, there's a web address there. So this is just, I've copied this from the SAFT website, so this is public information. I'll just read the red bits straight out. So we wanted to be able to minimize backlogs and give more accurate delivery estimates to our customers. At the bottom in red, before adopting the APS, it took 2 months for our Bordeaux site to replan its client order. 2 months, I can't actually get my head around that. To clear a backlog in the rail business, any replanning because of an unexpected event such as a broken machine would be a major headache too. But since we started using the APS at our Bordeaux and Poitiers site, we can now replan in 2 days. So significant difference, and a lot to do with the 2 days is the interdependencies from other factories as well. So they need to plan their site, and then as well they need to plan the site that's downstream from there to make sure they're getting all of the components and sub-assemblies. They had COVID as well, so the factory just completely, both plants just completely shut down during COVID. And as you can see here, again, this is on the website. It's not as simple as flipping a switch. So they had to do a lot of work in terms of the factory layouts to make it safe, in terms of the new regulations, in terms of distances and segregation between people. They had to sort out, right, what's the order book look like now that we're about to start again? What about what work in progress? We need to check all of that's up to date. Materials, purchase orders. Before we can start the factory again, we're going to need to buy some stuff. So they reset the model, reset all of the data, and run it through Sofco to use as part of the restart of that plant. And clearly there was a lot of other stuff that they had to go through as well, but getting that supply chain lined up was important. So yeah, COVID hit, and as a result of COVID hitting, in terms of the rollout project, there's nothing happened in France with SAFT for quite a while. They started to wake up again last year. We did some version upgrades in terms of the technology and the user experience. And at the minute, we're now just in early discussions with them in Valdosta in Georgia, but as well, I overheard some conversations from our account manager yesterday as well, that there's discussions starting about France, a further site in France and a plant in Sweden. And again, we've got that template in place now, so we can deploy it a lot more rapidly than we could for that very first project. So I've got a few minutes left. Hopefully you've got an inkling of who Sofco are. You've got an even better inkling about SAFT batteries and what it is they actually do, what we delivered there, and what they got out of it. So any questions, anybody?
You said they didn't release the numbers, but you've got to quantify how much their accuracy in terms of demand planning and KPIs that you can quote in terms of the improvements that were made before implementation?
Not off the top of my head. I'm really sorry. I'll have some ballparks hidden in the depths somewhere, but yeah, you've seen most of these slides are on the SAFT deck, so what they give us is what we can say. Yeah. Sorry, I'd love to answer. I'd love to answer it more because it would make us look good as well.
Just one, did they encourage, so you talked a lot about the constraints volumes. Were they encouraged to put in unconstrained or constrained demand in their planning?
The key thing was to put in the capacities and understand what was feasible, and as well baseline the capacities.
So they did their baseline planning based on the constraints and the actual
Yeah, and then depending on the exceptions that they got out, they can then take decisions. Okay, are there areas we can add capacities? Can we offset it to a different line? It offset it to the alternate lines automatically, but can we increase the working time on that resource? But if they're running 7 days a week, 24/7, clearly you can't. But things like labour, they could flex. So have a baseline, but within the system, give the space to flex the capacity.
If I may, the optimizer, how long did it run for one factory?
I think it takes somewhere between 30 minutes to an hour on this particular plant. It depends on the scale of the problem, and as well it also, because this factory is completely full, it's got to then work through every single alternate. Where we've got some food manufacturers, it runs in 5 minutes, you know, because you're dealing with a few hundred SKUs or maybe 1,000 and a simpler process, whereas with this it's got a lot of alternates to go through. So it varies, but as well, that's the full run. You can run subsets of it, providing there are providing you've got all of the interdependencies within that fence, and then it will run in a much shorter time. I think this is a particularly complex and big implementation. I know Eric Bernier, he's done many projects over there. He was the consultant that Saft put in. He said it's the most complex he's ever done, and I think I'm with him on that.
Could that runtime be reduced by adding more threads? For example, if it takes an hour to process 300,000 SKUs, could we add more thread on the server side to reduce the runtime?
Right, I'm going to have to put you in touch with one of our technical people for that. Sorry.
In Sofco, can you run like a whole network view?
Yes.
So you've got like 4 plants.
Yes.
And then do like your maybe a monthly.
Yeah. Well, this is
in order to sort of
absolutely
allocate to each of the sites and then do the more detailed schedule.
Yes, we do that actually with Greencore. So they do a longer term S&OP plan where the whole point of that is because they can make things on different sites, they've got that capability, they've got a preferred site which is the default, but they'll plan at a kind of rough cut level out to the S&OP horizon, make the decision where do we make, then allocate the demand to that particular plant and then plan on the local models in terms of the detail, having already solved that problem. So just as you described. Any others? One last one. It's 10:30 now. Okay, thank you for listening.